Hello everyone. So we are solving a problem of the day for Leetcode, and in this question we need to find the cell, whether the cell is reachable or not in given instant of time. So here we have the index for the starting cell, and we have index for the destination cell as our inputs, and we need to find whether we can reach the destination cell at exactly t second. Here t is given, right? And one thing to keep in mind that it is an infinite 2D matrix, and also we need to reach the destination in exactly, not less than and not more than t second. Now at first this question might look very much lengthy or hard, but it is very much easy question. We just need to find the exact optimal approach towards this question. So let us try to find out when can we not reach the final destination, because we can easily reach the destination by moving here and there, because it is mentioned that we can go to same cell several times, right? So we can take any path and we can go to the final destination because it is an infinite 2D matrix and we can move to same cell several times. So there can be infinite number of paths. We can easily take any path to reach the final destination. Let us now find when can we not able to move to the final destination in t second. So the solution is that if the time given is less than the shortest path, if the time given is less than the shortest path to reach reach from starting cell to the ending cell, then we cannot reach the destination, right? So for example, if our shortest path here will be like moving from here 1 2 and 3 4 and then the fifth one, right? So what we can say that here our shortest path will be like 5 steps, right? 5 steps, and we can say that if our time given is less, if it is less than 5 seconds, for example it is 4 seconds, then we cannot reach the final destination, right? So so here this is the optimal approach. Now let us examine how we can find the shortest path. So one thing stuck to our mind is that we need to have some recursion or DP to get the minimum path from starting index to final destination, but we don't require DP or any recursion to find the shortest path. We can easily find the shortest path from these given indexes only. So let us try to find out how we can find the shortest path, right? So let us first assume that our starting index is 0 0, and but here it is not 0 0 because it is an infinite 2D matrix. But for understanding, let us first assume that our starting the starting cell have index 0 0, and then our finishing cell will have index 0 1 2 3 and 1 2 0 1 2 3 4 5 6 0 1 2 3 4 5, right? So it will have 5 comma 3, right? So let us find out how we can find the shortest path here. So one thing we can clearly see that the shortest path will take a path from the diagonal of the square which is forming in that grid, right? So this is our grid, this is our whole grid which is forming between the starting and finishing part, and obviously the shortest path will be from will pass through the diagonal which is diagonal of the square which is forming in that grid, right? So we just need to form a square to get the diagonal path. So how can we form a square? So here the last index, destination index is 5 comma 3, right? So clearly it is visible that if we take the minimum of any row or column, then we will get a square, right? So here we can get a square at index 3 comma 3 from 0 comma 0 to 3 comma 3, right? It is clearly visible that from here to here we can have a diagonal. This is 3 comma 3 and we can have a square here, right? So this will be the diagonal path, and the remaining path will be the difference between the larger index, either row or column, the larger of both. It will be the difference between the larger and the minimum 3. So here it will be 5 minus 3, that is 2. So 2 will be the additional distance we need to cover, right. So in that case we can easily find out our shortest distance between the starting point to the finishing point. So try to find out how we can find the minimum distance. So as in this example, here we have 2 4 then 7 7, and we have the time 6 seconds. So we have 2 4 and then we have the 7 7, right. So at first we try to make them zero based, like we need to find the difference and make the make the starting index as 0 based. So we can make the row, like the row equals to 7 minus 2, and we will take the absolute difference between them, and we will get the column by taking the absolute difference between the column indexes. So here we get 5, and here we get the column as 3, right. So we get the row as 5 and column as 3. Now we can form the this example is transformed into this, right. So here it is 0 0, and here the final index is 5 3. Here the final index is 5 3. Now we need to make a square to get the diagonal path, and then we need to add the additional path in our answer, right. So to make the diagonal path, what we can do, we need to check the we need to select the minimum of the row or column. So here the minimum is 3. So obviously we will form a square diagonal at 3 3, at index 3 3. So let us tell the int diagonal, it will be the minimum of row or column. So after getting the diagonal, the additional path can be find out by take the difference between the highest index dividing it with the diagonal path, here 3 index, right. So our final we can say that in mean path, it will be the diagonal plus absolute difference between the column minus diagonal, or it will be the absolute difference between the row minus diagonal. Now obviously the diagonal will be one of the row or column. So in this one of the absolute difference will be 0, and other will give the additional path which we have to take. So this is the optimal approach of our solution. Now we need to code our solution. Let us move back to Leetcode and code our solution. Yeah. So this is the code. So what we need to do at first, we try to make the starting index as 0 based to easily find out the distance, like the minimum path. So we can make the int row equals to absolute difference between the final index minus starting index. We can make the column as absolute difference between the final column minus starting column, right. So in this we get the destination row and column. Now what we can do, we need to make a square, and then we need to make a diagonal index. It will be the minimum, it will be the minimum of row comma col, right. So what will be our minimum path? It will be the diagonal plus the extra distance, which will be the difference between any of the highest, like the larger index minus the diagonal, absolute of column minus diagonal, or it will be either the absolute of row minus diagonal. So in this line, either one of the term will be 0, either the col minus diagonal will be 0 and row minus diagonal will be 0, because diagonal will be the one of the row or column, right. So the additional length will be added to this minimum path. Now we have to have a check, like whether if our time given is less than if time given is greater than equals to minimum path, then we will return true, right, else we will return false. So this is the solution. Let us run. but it will have a edge case. Sorry, we have the mini path, okay, not an issue. We will have an edge case. Let us check which is the edge case we have to check. So here the edge case is that if we are let us go back to our code notes app and we check the edge case. So the edge case is that if the starting and ending cell is the same, like here it is given 1 2, it is the starting and it is the ending, starting, it is the ending cell. If the starting and ending cell is same and the time given is 1 second, right, then it give our code will give error, right. So what is the error here? What we need to find? Let us do a dry run. So what is there in our code? Yeah, submissions. So let us copy this. Yeah. So let us copy this and run it, right. So here we are getting returning true, right. So why we are getting true? Because the minimum path here it is 0 and the time given is obviously clear greater than the minimum path, right. So what fails here is that here it is given that we need in every second we need to move to the adjacent cell, right. So here the time is given 1 second. This means that in 1 second we need to move to the any of the adjacent cell, right. So when the starting index and when the starting cell and ending cell is same and the time is 1 second, we need to move to the any of the adjacent cell. So here we in after 1 second we will be in the adjacent of this ending cell, destination cell. We will not in the destination cell, right. So that's why it is giving false. It is giving false, but our answer is giving true. So this is the edge case. So we have just to check if our absolute path, if our minimum path is equals to 0 and time is 1 second, right. So this is the case when we cannot reach our destination cell in 1 second. If it is 2 seconds, we can come back. If it 3 seconds, we can waste the time elsewhere, right. But if it is 1 second and the minimum path is 0, like the same cell, the starting and ending cell is the same, we cannot reach the ending cell in 1 second, right. So this is the edge case. So we just need to upgrade our code. We just need to add an extra line. So what is our edge case? If our minimum path equals to 0, this means our starting cell and ending cell is same and the time equals to 1 second, then return false. Sorry, it will be t equals to 1 second. Let us run the code. Right, let us submit the code. Yeah, it works fine. And if you have any suggestions, any feedback for my first video, please comment down. I will love to get feedback from you guys. Thank you.